In this video, I'd like to talk about the math question of the day for Tuesday, May 30th, 2023. And with this problem, we need to factor this quadratic expression completely. And factoring quadratics is something that's typically taught in an Algebra 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And we just need to factor this quadratic here. But quadratics like these can be a little bit complicated because the coefficient on x squared, this 12 here, this is not 1. If this was a 1, then it would be a little bit more straightforward. But because it's not a 1, we can't essentially just work backwards from the FOIL method or the distribution method. We need to factor this by grouping. Essentially, we can take this 17x and split it into two different terms. Let's say plus a times x plus b times x. And then with the grouping method, we'll pair the first two together. Then we'll pair the second two together. We can pull the greatest common factor out from each. And then when we have those two separate terms, we'll have these expressions in parentheses that should be the same term. And we can factor that out from both terms. And if that seems a little bit complicated, it will make a little bit more sense as we go through it. So the general idea is that we need to split up this linear term into two separate terms with coefficients of a and b. Or in other words, we need to figure out what a and b are so that we can actually split this up. And to figure that out, well, we know that a and b have to add to 17. And typically students will draw a cross for this, that they have to add to 17. But a and b also have to multiply to the coefficient on x squared times by the constant term. So they need to multiply to 12 times 6, which is 72. So we're looking for numbers that add to 17 and multiply to 72. And to figure out those two numbers, we can take 72 and effectively just make a list of its factor pairs. For instance, 1 and 72, we could also do the negatives, minus 1 and minus 72, but we know they're not going to be negative since they have to add to this positive 17. So we can also do 2 and 36. It looks like 3 goes into 72, and it goes in 24 times. We can try 4. 4 would go into 72 18 times. We know that 6 and 12 are factors. We can also do 8 and 9. And we can stop right there since 8 and 9, those add to 17 and multiply to 72. So those are the two numbers we're looking for. We can maybe call this one A and this one B. It doesn't matter which is which. And we can now write this quadratic expression as 12x squared plus 8x plus 9x plus 6. And you can see that if we combine like terms, this is just 17x. Now, why do the numbers a and b need to multiply to the coefficient on x squared times by the constant term? That is a little bit less intuitive. You can prove it. It is absolutely true that that's the case. However, it tends to not be that intuitive. So most students will just memorize that fact. But it is clear that the two numbers have to recombine to 17. So at least that part is fairly straightforward. And at this point, we can combine the first two and the second two. We can use factoring by grouping. We can factor out the greatest common factor in each of these. And with the first two, we can factor out an x, and it looks like a 4. So we can pull out 4x. Here, we're left with 3x, and here, we're left with 2. And from our second pair, it looks like we can factor out a 3, so that we're left with 3x here and plus 2 here. And of course, you can check this by just redistributing there. But the way to tell if you're doing this correctly, or if this even is factorable by grouping, is that you'll end up with the same expression in parentheses for both of these terms. And from here, you can factor out this 3x plus 2 from this term and this term. So that when we factor it out, we get 3x plus 2. Here we're left with a 4x, and here we're left with plus 3. And this right here is what we think is our final answer. But if we want to check our work, which I highly encourage, what we would do next is re-multiply this out. So we can distribute this 3x to both, then we distribute the 2 to both. 3x times 4x, that's 12x squared. 3x times 3, that's 9x. 2 times 4x, that's 8x. And 2 times 3 is positive 6. And you can see that when we combine like terms, we do get back the 17x plus 17x that we originally started with. So we can feel very confident that this is the correct factorization of this quadratic.